Welcome to Algorithm video series. Today let's write a Python program to find the index of the last occurrence of a given target in a sorted list containing duplicate elements. So input of our program is a sorted list with duplicate elements and a target element. Output is last occurrence of the target element. For an example, here we have a sorted list. Our target is 30. Then our output is index 3, last occurrence of 30. Here 0, 1, 2, 3. In this list, this is the last occurrence of 30. Its index is 3, so output is 3. If an element appears multiple times in a sorted list, the last occurrence is the rightmost position of that element. And the first occurrence is the leftmost position of that element. And if an element appears only once in the sorted list, then that is the first and last occurrence of that element. Here in this example, if I take target as 30, then last occurrence of 30 is index 4. The first occurrence is index 2. If I take target as 20, it appears only once. So this is the first occurrence and also this is the last occurrence of this element. Okay, so now how to find the last occurrence of the given target element in the sorted list containing duplicate elements. For this, I'll use binary search algorithm. But normal binary search algorithm doesn't work here because in the normal binary search algorithm, we'll search for the target. Once it is found, we'll return its index and the message target is found. But here we want last occurrence of the target. Target can appear multiple times and we want the last occurrence of the target. For an example, here if I take target as 30 and if I apply normal binary search algorithm to find the last occurrence. So in the binary search algorithm, I'll take this as low, this as high. This is our search area now. So we'll find the middle element first. So we'll get 3 as our middle element. Then we'll compare the target element with the middle element. Here 30 is equal to 30. I'll take target also 30. Here middle element is equal to target element. So what our binary search algorithm will do? It will return its index, right? What is its index? 3. So it will return answer as 3. But actually here last occurrence of 30 is at index 4. So we can't use normal binary search to find the last occurrence of the given target element. So what to do? We need to modify our binary search algorithm. First, we need to find the middle element like we do in the normal binary search algorithm. Then we'll compare the middle element with the target element. Next, if middle element is equal to target element, in the normal binary search algorithm, we'll return the index. But here, in the modified version, what we need to do is, when middle element is equal to target element, we need to first store that index because it can be our possible answer. It can be the last occurrence of that target element. Okay, so first we need to store that index. Next, we need to continue search in the right side to see if element appears again. Because here we want last occurrence, we need to search in the right side of the middle element. If we find another target on the right side, then we need to update our result. That is the index. Initially, we'll store the index of the middle element. If we find another target, then we need to update that. If not, if we didn't find target element on the right side, then that means middle element is the last occurrence of the target element. So we'll return that index. So mid remains our result. Then here, if middle element is not equal to target element, then what? If middle element is less than the target element, then we'll search in the right side, like we do in the normal binary search. If it is false, then we'll search in the left side, like we do in the normal binary search. Here, we need to modify this scenario. When middle element is equal to target element, then we need to store that index and we need to continue search in the right side of the middle element. So here we can see the difference between normal binary search and modified binary search. If you want to find the first occurrence of the target element, then we need to store the index of the middle element and we need to search in the left side. Here we want to find the last occurrence of the target element. So when target element is equal to middle element, we need to store that index and we need to continue search in the right side of the middle element. That is the difference between the first occurrence and last occurrence. Next, let's take few examples. Let's take target as 30. We want to find the last occurrence. So let's find the middle element. Low plus high truncated division 2. So we'll get index as 3. This is our middle element. Then compare 30 with target 30. It is true. Target is equal to middle element now. Now what we need to do? To find the last occurrence, first I need to store the index of the middle element. Because target is equal to middle element, I need to store the index. And now search in the right side of the middle element. For that, I'll take low equal to mid plus 1. So now this is our search area, right? Find the middle element now. So 4 plus 6 truncated division 2. So we'll get 5. And this is our middle element. Compare middle element with the target. 40 is equal to 30. No, it is not. Actually, middle element is greater than target element. So we need to search in the left side, right? High becomes mid minus 1 now. So high will point to here. Then we'll find the middle. So we'll get this as middle. Compare the middle element with the target element. It is equal. When target is equal to middle element, what we need to do? We need to store that index in this variable, right? So here now, answer is 4. Update this variable. Now we need to search in the right side. When target is equal to middle element, we need to store that index. We need to search in the right side. To search in the right side, we need to take low equal to mid plus 1. So now low becomes this one. But here you can see low is greater than high now, right? When low is greater than high, we need to stop binary search. So stop the search. And this variable will hold answer now, that is index 4. This is the last occurrence of our target element, that is 30. Let's take another example. Let's take target as 444. First find the middle element. 0 plus 7 truncated division 2. So we'll get 3. So this is our middle element. Compare the middle element with the target element. Middle element is not equal to target element. Then check whether target is greater than middle element. Yes, here target is greater than middle element. So when target is greater than middle element, this is a search area now. So again find the middle element. 4 plus 7, 11, 11 truncated division 2, 5. So we'll get this as our middle element. Compare the middle element with the target element. Yes, here target is equal to middle element. So store that index and search in the right side of the middle element. So low becomes mid plus 1. Now this is our search area. Again find the middle element. Low plus high truncated division 2, 6 plus 7, 13 truncated division 2. So we'll get 6. This is our middle element. Compare the middle element with the target element. Yes, it is true. So store its index and search in the right side. So here low becomes mid plus 1. So now this is our low and high. Find middle element and compare middle element with the target element. It is true. Then what we need to do? We need to update answer now. Answer is 7. Then we need to search in the right side of the middle element. So low becomes mid plus 1. Low is actually 8 now. Now low is greater than high. So we need to stop binary search. So this is our answer. That is 7. The last occurrence of 444 is at index 7. Let's take 111. Compare the middle element with the target element. Target is less than middle element. So search in the left side. High becomes mid minus 1. Now find the middle element again. Compare the middle element with the target. It is true. So store its index. Then search in the right side of the middle element. So here low becomes mid plus 1. So here now this is a search area. Find the middle element. Low plus high truncated division 2. So we'll get this as middle element. Compare the middle element with the target element. It is equal. So we need to store its index. So 2. And we need to search in the right side. So now to search in the right side, low becomes mid plus 1. Now low becomes 3. But here low is greater than high now. So we need to stop the search. Answer is 2. Next, let's write the program. Here we have a normal binary search algorithm. So let's modify this binary search algorithm to find the last occurrence of the target element. So for that, we need to modify this section. When middle element becomes target element, we need to store that index. For that, let's take a variable. Initially, we'll take its value as -1. Then here, instead of returning value, answer equal to mid, we'll store that index and we need to search in the right side of the middle element. To search in the right side, we need to take low equal to mid plus 1. And here, we need to return answer. If target is found, then this function will return the last occurrence of the target element. If target is not found, then it will return -1. That's why initially I took answer as -1. If target element is not found, then it will return -1. So no need to change anything else. Let's save this and execute this. Number of elements in the list, let's take 6. Enter the numbers in the ascending order, a sorted list. Let's enter target as last occurrence is index 2. Last index is 4. Okay, so this is how we can find the last occurrence of the target element in the sorted list containing duplicate elements using binary search algorithm. Okay, so that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.